Alright, we've been talking about expansion of series. Now we've used the Simpson's rule and the trapezium rule, so we're trying to use the Maclaurin's rule to expand something like this. So this is the series from 0 to 1 sine x upon x dx. We said, how do we do this kind of stuff? It's just a simple thing. What we need to do is to expand sine x first. For those of you, what I was trying to do on the board initially was to expand sine x, but I don't think I need to do that again. For those of you that have the videos, no, the video is always there. For those of you that have watched the Maclaurin series, so you should use the Maclaurin series to expand sine x by yourself. And if not, you should go and watch the video. Sine x is always expanded this way: x minus x cubed over 3 factorial plus x raised to power 5 over 5 factorial minus x raised to power 7 over 7 factorial plus to infinity. This is the expansion of sine x. But what's the question we are asked to evaluate? We have sine x. We have sine x all over x, right? So sine x all over x means dividing all these values by x. And that's going to be what? X all over x minus x cubed over 3 factorial x, we are dividing by x, right? Plus x to the 5th power over 5 factorial x minus x to the 7th power over 7 factorial x plus to infinity. So we can see here that x cancels x here. So we are left with 1 minus, if x cubed is divided by x, what this means is x cubed is x times x divided by x. That means 1x cancels 1x. We are left with what? X times x, that is x squared. So that means x squared is left here. But do not forget the 3 factorial plus, if x to the 5th power is divided by x, it will be x to the 4th power left over 5 factorial minus x to the 6th power now over 7 factorial. We've just done sine x divided by x. Because the relationship, the operator is plus and minus, we have to distribute the x to everything there. I'm sure you know what we did there. So now let us use 1 from 0 to 1 sine x over x dx is equal to, since this is our sine x over x, it can also be written as from 0 to 1 of 1 minus x squared over 3 factorial plus x raised to power 4 over 5 factorial minus x raised to power 6 over 7 factorial to infinity. Right? That is what we did. Because we expanded sine x over x, this is the value. That is why we are writing it here instead of writing sine x over x again. This is by using the expansion formula. We are evaluating this integral using the expansion formula. If you are not asked to use it, I won't advise you to use it, because you need to be expanding using the Maclaurin series in case it's a series you do not know about before. After that being the case, now you are going to integrate everything here. How do you integrate this? Integrate 1, that's going to be x, minus integrate x squared over 3 factorial, that will be x raised to power, add 1 to 2, that is 3, all over 3 times this 3 factorial originally, plus integrate s raised to power 4 over 5 factorial, that's s raised to power 5, you're adding 1 to that 4, over that 5 that you got, times 5 factorial, minus x raised to power 6 will become x raised to power 7, right, all over 7, we are integrating it, times 7 factorial. All this now between the boundary 0 to 1. Do not forget that as well. So keep this first. Let's continue in the next video.